Good day everyone. Welcome to the first lecture of this video series on machine learning. So in this particular lecture series, we will discuss the machine learning. What is a machine learning? Okay. And we will discuss the different approaches of discussing various algorithms in machine learning. So we will discuss the different types of machine learning. For example, supervised learning. We will discuss about the unsupervised learning. Okay, and we will also discuss about the reinforcement learning. We will discuss various algorithms that are associated with the supervised learning. So first of all, we will discuss what is this supervised learning, and then we will discuss the algorithms, or we can say the different learning algorithms for supervised learning. We will also discuss unsupervised learning and the algorithms associated with it, reinforcement learning, and all the algorithms associated with this. Okay, so for understanding this particular lecture, this particular course, we will divide this machine learning course into two parts, or we can say we will have two different approaches. One is the data approach, data based approach. Okay, and the other approach that we will focus on is the probabilistic approach. Okay, so we will discuss how this probability, the concepts in the probability, can be used to discuss the concepts or the algorithms in the machine learning, or we can say how we can use probability to learn the data. Okay, and also we will discuss how our machines can use another approach, which is also called a data based approach, to learn the different patterns or to gain the intelligence from the data itself. Okay, so these will be the two approaches that we will be taking care in this particular course. Okay, so this particular course will not only be a theoretical description about different algorithms, it will also parallelly do the programming of these algorithms, learning algorithms, and for programming we will be using Python programming language. Okay, so it is your choice, you can use any other programming language, but in this particular course we will be mainly focusing on the Python. And some important libraries in the Python that we will be using are the NumPy library. The second library that we will be using is the Pandas library. Okay, we will also use scikit-learn, and matplotlib. Okay, so these are the important libraries that we will be using in the programming exercises if in machine learning. So I will also put some video lectures while I will be discussing briefly these different libraries, so that we get used with the different functions that are available in these libraries, and then we can use these libraries into our programming exercise. Fine. So before going deep into the machine learning, let's first see what is this machine learning. Okay, then only we can move forward. Okay, so what is the machine learning? So let me define it. So basically, machine learning is the science, or we can say the art of programming computers. So it is the science or art of programming the computers so that they can learn from data. Okay. So what I mean to say, in machine learning, our aim is to feed data to the computers, And from this data, these computer systems, they extract some important relations in the data, and using these relations they learn those relations, or we can say those inferences from the data itself. Okay, so we should first understand what is learn. When we say that a computer learns, fine, so we will understand this shortly. So this is one of the definition of machine learning. The another definition that is used is ML is the field of study that gives computers the ability to learn without being explicitly programmed. What does this mean? So you can see that there is a relation with this definition. So this is definition 1. This is our second definition. So you can see that here in this definition we have said that it is the science of programming computers so that they can learn from data. So this definition is also the same, is the field of study that gives computers the ability to learn. But it has one additional sentence, or we can say part of sentence, without being explicitly programmed. So let's say, for example, you are writing a program. If A is greater than B or A is greater than 10, print A is greater than 10. Else print A is less than 10. For example, if I have a computer running this program, and then to this program I am feeding data A is equal to 20. And this particular program will print A is greater than 10 because A is 20. But can we say that this machine which is running this particular code, is this particular thing a machine learning algorithm, or we can say a machine learning program? Can we say it? No, it is not a machine learning program. Or we can say here, if a computer is running this particular part of program to give an answer to some query, then this is not learning anything. So here we have explicitly programmed our machine using some rules. We have explicitly given some rules, and based on those rules it is processing the data. Okay, this is not considered as machine learning, because in machine learning our system should learn on its own what this A is, and based on the value it can take different decisions. For example, here it is taking a decision whether I should print this statement or this statement, but the decision are not taken by the system, by the computer on its own. We have explicitly programmed here what decisions should be taken. This is not considered as a machine learning. So machine learning is when our system is learning, but there are no well-defined rules explicitly programmed. Okay, so that is the difference between a program and a machine learning program. Okay, another definition. So that very definition will help us to understand what is called a learn. Okay, so the third definition that is used is, so I will write it here, the third definition related to machine learning. So machine learning is said, or we can say a computer or a system is said to learn. So when do we say that a system is learning? a system is said to learn from some experience E, okay, with respect to some task T. So this is our experience and this is some task. Okay. So we say that a system is learning from experience E with respect to some task T when the performance P of a system on task T improves with experience E. So what is the meaning of this? So for example, we have some task. Okay, let's take the example. Let's say I have a task of detecting a cat in an image. So this is our task. Okay, so what is the experience here? Experience is, let's suppose first we are giving hundreds of images, cat images, and hundreds of non-cat images to our system. Okay. So now let's see. So our task is detecting a cat in an image. If we have a system, we say that this system is learning when by increasing the experience means having more number of cat images and having more number of non-cat images. So by increasing E, the performance of this system improves on T. So what was the T? Detecting a cat in an image. So if it is performance, so what is a performance here? Performance can have different definitions, but here we can say one of the definition. For example, performance means correctly predicting or correctly depicting the cat in an image. Okay, or we can say the accuracy here is a performance. So if we have a system, some system, we say that particular system is learning if its experience, if by increasing the experience here means increasing the data. Okay, if by increasing the experience its performance on this task improves, then we say the system is learning. If the system's performance is not improving with experience, then we say that it is not learning. So this is the definition of machine learning or learning. Okay, so here we are giving learn. So we have a system we can say machine. A machine is said to learn from experience E with respect to some task T when the performance of a system on task T improves with experience E. Okay, let me give another example. Let's take the example of let's take the task as spam filter example. So the task here is correctly classifying email as a spam. Okay, so this is our task, and the performance measure will be the accuracy again, whether our system is able to accurately classify an email as a spam or not spam. So what will be the experience here? So experience here will be the n number of emails, which are among which some are spam and some are not spam. So if we improve it, if we increase its experience, that means if we give more number of emails as spam and non-spam, and then our system's performance on this particular task improves, then we say that our system or our that particular algorithm is learning. Or we can say, so let's suppose I have some algorithm I have created, and this algorithm, if I am increasing its experience, so that means I am giving more number of emails, and I am telling to this particular algorithm which emails are spam and which emails are non-spam. Then if some other email comes to this algorithm, some other email which is it has not seen, it has only seen some emails which I have fed it, now it sees some spam email, or we can say some email, then from its experience, so whatever it has learned from this experience, from this data, it will predict whether this email is a spam or not. So if I have an algorithm and with experience, increasing its experience, its performance on the task improves, then we say this particular algorithm is a machine learning algorithm. Okay. So I hope you understood which system to which, or we can say to which algorithm we will say that it is a machine learning algorithm. Only those algorithms where the algorithm is learning on its own without being explicitly programmed. So with experience, so experience here is a data. So when we are feeding a large amount of data to the algorithm, this particular algorithm learns the patterns in this data. And based on those patterns, if it finds out some other data which was not included in this data, it will find those patterns in this particular data as well. Okay, and if it is able to find those patterns in this data as well, it will determine whether this email is spam or not. Okay, then we will say that this is a machine learning algorithm. Okay, so up till now you can see we have completed what is the machine learning. Now let's see why we have to understand the machine learning, or we can say why we are learning this machine learning. The first important thing is that our machine learning automatically learns. Okay, so there is no human intervention. It automatically learns the patterns. Okay, so that means automatically learns means, so if there are updates in the data, so our machine learning will tune itself. So let's suppose if we are doing the traditional way, so in the traditional way, whenever there are updates in the data, we may have to change the rules, explicitly change the rules. But when we are using machine learning, there we don't have to change anything. Our machine learning algorithm, whenever there are updates in the data, it will automatically learn the patterns in those updates as well. Okay, another important thing is that machine learning algorithms helps us to get insights about the data. What does that mean? For example, if I have a data which is of, let's suppose, 2 GB or 2 TB, so it will be an extreme large amount of data. Manually, I cannot process this particular data. What is the meaning of processing here? It means that, let's suppose, I have to find some patterns in the data. Okay, let's say I have the data of customers who are buying some items. Okay, and this data is a huge amount of data. Now, if I have to find some patterns in this particular data, manually it will be extremely difficult if we do manual searches. Okay, but if we use machine learning algorithm on this particular data, we can use a machine learning algorithm that will find patterns in this particular data, and we can see what are the patterns in the data, and based on those data we can gain insights about the customers. Okay, so this comes under the data mining. So that means we have a large data, or we can say we have big data, and in that big data we apply a machine learning algorithm, and that machine learning algorithm is finding the patterns which are very difficult to find manually, and based on those patterns we will gain insights about the different types of data, and based on those insights we can take business decisions. Okay, so that is why machine learning is very important, and it is also becoming important in various industries, because industries are getting the data, and from the data they are finding the patterns, and from the patterns they are getting the insights, and from those insights they make better business decisions to make their business profitable. Okay, fine. So this is why we are learning machine learning. Now, there are different types of machine learning systems, or we can say there are different types of machine learning categories. So, or we can also say there are different machine learning tools. So let's different machine learning categories, or different types of machine learning systems, or what are the different machine learning categories. Okay, so there are different ways or methods of dividing machine learning into different categories. So first categorization is done depending upon the nature of experience. So you already know that in machine learning there are three things: experience, task, and performance. So depending upon the nature of experience here means data, depending upon the nature of data. Okay, we are dividing machine learning into two broad categories. One is called online learning, and another is called bash learning. So online learning means that if our system, or we can say our algorithm, is learning incrementally from the data. So what does that mean? We have some data. So let's suppose I am getting data of the customers. I am taking data of customer 1 and giving it to the algorithm, and algorithm is learning patterns in this particular data. Then I have the data of customer 2. I will again give to the algorithm. It will learn from that particular data, and it will update its rules accordingly. Okay, so this is incremental, or we can say training on the fly. So whenever the data is available, we are feeding that data to the algorithm and it is learning from that particular data. Okay, or we can say it is training from the data incrementally. Fine. The second part is the batch, or second category of algorithms are the batch learning. So in batch learning, we have a machine learning algorithm, and to this algorithm, this learns on large amount of data. When it learns a large amount of data, so we have a trained algorithm. So we were having a machine learning algorithm. To this algorithm, we fed data, and this algorithm learn the pattern in this particular data, and we have a trained algorithm. Then we take this trained algorithm and we deploy it. Deploy means that now if we give some unknown data to this particular algorithm, from this unknown data, it will do the predictions. Okay. For example, if I have a data of diabetic patients, for example, if I have a data like this, for example, I have weight of patient, age of patient, and I have another thing whether it is diabetic or not. So let's suppose weight is 50 kg, age is 70, and diabetic, yes, it is diabetic. Another is weight is 70 kg, age is 30, so it is saying no. There may be different patterns here. So this was our diabetic data. So we took this data and we give it to an algorithm, some algorithm that we may have created. This algorithm will learn when a patient is diabetic and when a patient is not diabetic. Okay, so it learns the patterns in this particular data. So here, this is our input, weight and age, and whether he is a diabetic or not, this is our output. So we give this data to our algorithm. Our algorithm finds the patterns in this data, and we have a trained algorithm. Then we deploy this trained algorithm. What is the meaning of deploying? Deploying here means that now let's suppose I have an input data of some unknown patient. Input data means I have his weight and his age. Okay. Now using my algorithm, I have to find whether this person is diabetic or not. So I will give this data to this trained algorithm and it will give the output. It will predict whether the patient is diabetic or not. And how it is going to predict? It is going to predict by comparing this unknown data with the patterns that it has found in the known data. Okay. So this is called a batch learning. So that means we are first giving a complete data set to the learning algorithm and it learns, and then we train it. So what is the disadvantage? The disadvantage is there now if we have new data. Let's suppose I have new data available. Some patients came, I have their weight, I have their age, and I have also whether they are diabetic or not. Now I also want to incorporate this data as well. What I have to do, I have to take this algorithm again and I have to again train it with this new data, both with the old data and the new data. So it will take a lot of time. So in most of the cases, it takes at least 1 day to do the complete training. However, in online, whenever new data is available, we can train our algorithm on the fly. Okay, but in the online also there is one important parameter which is called learning rate. Okay, so in online thing we have to keep in mind this learning rate. So learning rate means how fast the system should adapt to the new data. So for example, the new data is coming to the system and it is learning based on the new data. So whether it should give more weightage to the new data or not. If it is giving more weightage to the new data, we say that it is learning rate is high. Okay. And it will learn very fast. Okay, but the disadvantage is that if we are giving more weightage to the new data, that means we are losing some information related to the old data. Okay, so high learning rate means we are giving more weightage to the new data. So it will result in it will make quick adapter to the new data, but it will result in losing the information about the old data. Okay, and however, if we have low learning rate means that it will adapt to the new data very slowly. Okay, so that means it is keeping the information about the new data as well as the old data. And the disadvantage with this is that the learning will be slow. Okay, but the advantage is that it will be very less sensitive to noisy data. Because if some noisy data is coming in between, so since it has low learning rate, that means it is not giving more weightage to the new data, so this noisy data will not make high changes to our algorithm. Okay, so you have to decide whether you want a high learning rate or a low learning rate. Okay, so this was about the one category of machine learning, that is online learning versus batch learning. So these are the two different categories of machine learning when we are doing the categorization based on the nature of experience. So another categorization will be on the basis of task. So the second categorization is based on the nature of task. Nature of task. So that means that is whether for learning a task. So for example, if we have a task of predicting whether an email is a spam or not. So the task is predicting whether the email is spam or not. But for learning this particular task, learning the data patterns, okay, whether for learning the data patterns, or we can say whether for learning the task, we require human intervention or not. Okay, that means whether we require some human intervention or not for learning. Based on that, we categorize machine learning algorithms into three different categories. One is the supervised learning. The second is unsupervised learning. And the third is our reinforcement learning. Okay, so let's discuss each of these categories in detail. What is supervised learning, what is unsupervised, and what is reinforcement. So there is another category which is also called semi-supervised. So we will see also this one as well, but these are the three broad categories into which we are dividing the machine learning algorithms. A machine learning algorithm can be a supervised, unsupervised, or reinforcement. So let's first see what is supervised learning. So basically you should first know in learning what we are doing, we are trying to do, or we can say what we are trying to do in machine learning. So basically we have some data, already we have some data, a large amount of data. Okay, so this data may have an input as well as output, or in some cases it can have only input, okay, no output. Our machine learning algorithms learns this data, and now after that, if this algorithm has some unknown data, it receives some unknown data. Based on what it has already learned, on this unknown data, it will give us the output. So we have an unknown data, only input we have. Based on what our algorithm has already learned from this data, it will give the output, or we can say it will predict the output of an unknown data. Okay, so in supervised learning, what we are doing, when our algorithm, our machine learning algorithm is learning, so we know that it is learning on some data. If our algorithm is learning on the data, and this data has both input as well as output given, both input as well as output is given, then this algorithm is called a supervised learning. So that means we require data, and that data should have both input as well as output. So let me make you understand with the help of an example. For example, I have, let's suppose there is one data set called the iris data set. Okay, so iris data set is a data set of iris flowers. Okay, in this data set, what these personalities have done, they have created a data set. So iris, there are three types of iris flowers. So one is setosa, this is one category of flowers. Okay, another category is, I'm not remembering the name, there is another category of iris flowers. So I don't know the name, but one is setosa, another category is there, and third category is also there. So this is called category 0 flower, category 1, and category 2. So an iris flower can be of category 1, can be of category 0, category 1, or category 2. So there are three types of iris flowers. Now, how we can say the flower is of category 0 or category 1 or category 2? What the people which have created this particular data set, this iris data set, what they have done, they have found 4 parameters related to a flower: sepal length, sepal width, sepal height, petal width, and petal length. Okay, so these are the 4 parameters they have taken. They have taken a total 150 flowers of iris type, and they found their sepal length, sepal width, and petal length, and they also found their category. So whether it is a 0 category flower, 1 category flower, or 2 category flower. So they have these for 150 flowers. Now let's suppose if I am getting these 4 parameters of some flower. some iris flower. I am getting it a sepal length, sepal width, petal width, and petal length. Now, and that particular thing, or we can say those particular values are not there in these 150 flowers. My aim is to get whether it is of category 0, category 1, or category 2. And how I can predict it? So I have input. Input means I have sepal length, sepal width, petal width, and petal length. And I require output. So that means I have to predict whether it is of type 0, type 1, or type 2. So how can I do it? So supervisor learning says, what it says, that I will have an algorithm, machine learning algorithm. To this algorithm, I will train it. Train it on data. On which data? The data which is already available. But you can see the feature of this training data, the data on which we are training the algorithm. This data has both input as well as output. Okay. So this data learns, it learns the relationship between input and output. Okay. And when it learns the relationship between input and output, we have a trained algorithm, or we can say trained system. Now, if this trained system gets some unknown data, unknown input data, okay, so unknown input data means it will get sepal length, sepal width, and petal length. Based on the relationship that it has already learned from this trained data, it will give us the output, whether this flower is the category 0 flower, category 1, or category 2. So this is our prediction. But you have to remember, our prediction can be wrong also. Okay, but we should design an algorithm in such a way that our prediction is right most of the time. So this is called supervisor learning. So what is supervisor learning? In supervisor learning, or we can say the machine learning algorithm, where our algorithm learns on a data, and this data has both input as well as output, then it is called supervised learning. So in this particular category, our algorithm learns the relationship between input and output. Okay, now see this output that we are predicting. So for example, here, what was the output we are predicting? 0, 1, and 2. So these are the three values. So here output was discrete. Discrete means it can be 0, 1, or 2. But there is also a possibility, for example, if I have some other learning algorithm that tries to learn the price of cars or price of house. We want to design a learning algorithm, machine learning algorithm, that predicts the price of house. So we will first train this algorithm on a data. So that data will have input and output. What is the input and output? For example, we may have the size of house, number of bedrooms, okay, and locality, and output will be price. So these are input features, or these are also called parameters, input parameters, and we have the output price. So first we will give this data to our learning algorithm. It will learn from this particular data. Then if we give the input parameters of some unknown house, it will predict the price. Okay, so this is also a supervised learning, but here output is price, and we know price can be continuous, it can be any value. Okay, So that means in supervisor learning, when we are predicting the output can be discrete or it can be continuous. So when the output is discrete, we say that it is a classification problem. And when the output is continuous, we say that it is a regression problem. So for classification problem, we have different algorithms, learning algorithms. For regression problems, we have different learning algorithms. So first you have to determine whether you want to design a machine learning algorithm for a classification problem or for a regression problem. That you can easily determine from the output, whether you want a discrete output or a continuous output. For example, for classification problems, we have different machine learning algorithms. One is the logistic regression, another is KNN. Okay, for example, neural networks, they are also used for the same. Okay, SVMs, they are also used. So these are different algorithms for classification problem. For regression, we have linear regression. Okay, linear regression, and we can use other also. For example, we can use decision trees and other things, but decision trees are also used for classification problems. Okay, so we have to discuss all these algorithms: logistic regression, KNN, neural networks, SVMs, linear regression in great detail, and we will also write their Python codes. But in this particular lecture, we are only giving the brief discussion: what is supervised, what is classification problem, what is regression problem. So this was all about the supervised learning. Now the second part is, or we can say the second type of learning is unsupervised learning. So in unsupervised learning, our algorithm learns on a data which has only input. So there is no output. So that means we have unlabeled data. So in supervised, our algorithm was learning on a labeled data. Labeled means that we have output is given. So we have a data, input data, and its output is given. So every data is labeled. So in unsupervised learning, our data, we have only input. There is no output. So it is an unlabeled data. And our supervised learning learns patterns in this data. For example, let me give an example. Let's say I have a data of persons who are using Facebook. Okay, I have the data, for example, who is connected to whom, and let's suppose I have a friend, what are my mutual friends with some other friend. Okay, so it has only input data related to each user. Okay, Facebook user. Now we can use unsupervised learning to make clusters in this particular data. For example, if these were the people, so this was connected with this one was connected to this is connected to this, we can use an unsupervised learning to make that this is a cluster where one is connected to another, they are connected to each other, this is another cluster. Okay, so clustering can be done using unsupervised learning. And why it is useful? This clustering is useful. It is useful for various ways. I will show you why it is useful. For example, let's say what you want to do, you want to find the mutual friends. So let's suppose these two are friends with each other and you have to find the mutual friend. If we are able to make a cluster, we can find mutual friends with each other. Okay. Not only that, we can find how many distinct clusters are there, or we can say how many distinct groups are there if we have to do the grouping. For example, if I am writing some blog, okay, let's suppose I have wrote a blog on social media. So there is some blog, so I have my website. For example, my website is janibbashir.com, and different users are visiting this website and reading some blog on this particular website. Okay, now from that particular data I can make clusters. For example, how many among them are man clusters, women clusters. Now if I find that, let's suppose 60% of male are reading my blog and only 40% of women are reading my blog. So from this particular information, from this cluster, I can say that I have to target male audience more, because they are more interested in reading my blogs. Okay, likewise, if I can get some more information from the clusters, I can refine my website accordingly. Okay, so this is one example. This unsupervised learning is also used in anomaly detection. Anomaly detection, for example, in fraud detection. Or we can say credit card or any business fraud detection. This unsupervised learning is used. Another example is in dimensionality reduction. What is the meaning of dimensionality reduction? This is also usefulness in feature extraction. So what is the meaning here? Dimensionality reduction or feature extraction, it means that I am trying to, let's suppose I have 10 input parameters. So these are a lot of parameters, but using unsupervised, I can combine two or more related parameters into one. So that will decrease our total number of input parameters. Okay, and how we are going to do it, how dimensionality reduction is done, we will discuss this in great detail, but at this particular point you have to only understood how it is useful. Okay, so this was unsupervised learning. So in unsupervised learning, we are learning based on unlabeled data. So we have an unlabeled data and our learning algorithms find patterns in this data. So in supervised learning, our algorithm was learning the relationship between input and output. But in unlabeled data, our algorithm is finding interesting patterns in the data. So that is the difference between the supervised learning and unsupervised learning. The last part is the reinforcement learning. So in reinforcement learning, we have a system or we have an algorithm which is also called a agent. So it learns by interacting with its environment. What does that mean? So our algorithm takes some policy or it takes some decision in response to an input. So when this algorithm is receiving some input, it is taking some decision. And based on this decision, our system receives a reward. So it may receive a negative reward or a positive reward. And based on this reward, it updates its decisions. So let me give an example. For example, let's say I am creating an algorithm, or I am creating a system that will play chess. Okay, what I am going to do, I will have a chessboard. On one side this algorithm or this computer system is playing, and on another side some player is playing. Okay, so this player is making some decision, it is making a move, some move. This algorithm has an input is the complete board, complete chessboard, and based on this input it will also make some decision, make some policy. Now it is making decisions one after other. At the end this algorithm will receive a reward, win or lose. So if it is receiving a reward win, that means it will say that my decisions were correct. If it receives the reward loss, it will change its decisions. It will now again play with this player till, so it will play thousands of times. It will make all the possible decisions, and at the end it will receive win or lose. So when it is playing again and again, at the end it will have the policies, or it will have the decisions which will help him to play in any condition. Okay, so here algorithm is learning by interacting with the environment. So it is receiving a reward, win or lose, and based on that it is learning. So this type of learning is called reinforcement learning. Okay, so we have to discuss, we will discuss the algorithms related to the reinforcement learning, and we will also see how we can implement those algorithms in Python. Okay, so as I said, so this was all about the supervised, unsupervised and reinforcement, but there is semi-supervised also. It is same as the other categories. So in semi-supervised it is the combination of supervised and unsupervised. So that means when an algorithm learns on a data, some part of the data is labeled, some part is unlabeled. What does that mean? For example, let's take the example of Google Photos. So what Google Photos does, it has the data. What is the data? Images, or we can say photos. It will check these photos. It will find, let's suppose, photo 1, photo 2 and photo 3. These three have same person in these. For example, photo 1 has 3 people, photo 2 has a single person, it has 4 persons, and on all these 3 photos there is one common person. So it will make one category of these photos. Likewise it will make another category. Okay, so here it is an unlabeled data, so it is making clusters. Okay, so this is unsupervised learning. Now what it will do, it will ask the user, okay, whether this category belongs to family, photos or friends. So if I am giving it an information only once that it is a family photos and this category is friends, so now I have labeled it, it becomes a supervised learning. So it is using both unsupervised for clustering, and it is also occasionally taking information from the user whether to give a label. Now whenever it finds a photo that has this particular person, it will put that photo into family category. So this type of learning algorithm, which is using both unsupervised mechanism and supervised learning, is called semi-supervised. Okay, so this is the second categorization of machine learning algorithms. The third and the last categorization is based on the performance, or we can say nature of performance. Nature of performance means that whether we are comparing new data with trained data. So we are comparing the new data for which we have to make the output prediction. We are comparing it with the trained data, and based on that we are predicting the output. Okay, that is one. Another is instead detect patterns in the training data and build a predictive model. Okay, fine. So here we, in this category of machine learning algorithms, for predicting the output of a new data, we are comparing it with the trained data, or we can say the data that is already available with this. Okay, so if we are, and then we are predicting what is its output. However, another categorization is that we first make a model, predictive model, based on this trained data. Then we give a new data to this predictive model, and this predictive model will predict the output. Okay, so this type of machine learning algorithm is called instance based machine learning, and these types of machine learning models are called model based machine learning. Okay, so this was the categorization of machine learning algorithms. So this completes this particular lecture also. So we completed here what is machine learning and what are the categories of machine learning. What we are going to do, so we will only focus on the supervised learning, unsupervised learning, and reinforcement learning, on these three categories. And these categories will also cover this instance based, model based. It will also cover online and batch learning as well. So we will first start with the supervised learning, then with the unsupervised learning. We will discuss the algorithms associated with supervised learning. We will also write their Python code. Okay, then we will have unsupervised learning. We will do the same, then the reinforcement learning, and it will be the complete discussion of this lecture series. Okay, so from the next lecture we will first give some brief idea about the Python. So briefly we will learn about the Python, what is Python and how we can use it in our machine learning programming exercises. Then we will start with the supervised learning. So let's meet in the next lecture. Till then, goodbye.